Welcome to this module on statistics, and in this video we shall be talking about why do we have n minus 1 for the sample data and n for the population data. So far we already understood the formula of variance and standard deviation. Variance, which is nothing but standard deviation square, is nothing but summation of x minus mu square divided by n. Now this exact formula changes for the sample data. In case of sample data, the variance is nothing but summation of x minus mu square divided by n minus 1. Now, why do we have this n minus 1 for sample data and n for this population data? Well, there is a theory behind it. We have to take a small example and try to understand why do we have this. This is basically called as Bessel's correction. This method corrects the bias in the estimation of the population variance. It also partially corrects the bias in the estimation of the population standard deviation. The idea behind this is that this is a more unbiased measure of variance than the usual definition. Let's try to take a small example and try to understand why n-1 for sample and why n for population. Imagine you have a book shelf. Let's say the total thickness of the first 6 books. Imagine you have 6 books. Turns out to be 158 mm. So let's say here we have 158 mm as the total thickness, which definitely means the mean will be 158 divided by 6, which will be 26.3. That's my mean thickness. Now you take out and measure the first book's thickness, which is called as 1 degree of freedom, and that is 22 mm. Let's say the first book thickness was, let's say, 22 mm. Now you have 5 books. What is the total thickness of 5 books? It is 158 minus 22, which is 136 mm. Now we have 5 books. Now you measure the second book, which is second degree of freedom, and find it to be 28 mm. Let's say the second book is 28 mm. Now here, what will be the total thickness left? 136 minus 28, which will be 108 mm. And now you have 4 books. And the same process goes on. In this way, by the time you measure the thickness of the 5th book individually, which is here you are selecting the 5th book. When you are doing that, which is the 5th degree of freedom, you automatically know the thickness of the remaining 1 book. Let's try to take examples. Now here we have 4 books and 108 mm. Let's say the third book is like 30 mm. Now here the total width will be 78 mm and we have 3 books. Then the fourth book, let's say, is 25 mm. So here the left out will be 53 mm and we have 2 books. Imagine at this point of time where you have 2 books, the total thickness is 53 mm. Here you are picking the 5th book, and let's say the 5th book, which is called as the 5th degree of freedom, is found to be, let's say, 20 mm. When you find the thickness of the 5th book, it is quite understood that the 6th book, the final book's thickness, is going to be this minus this, which will be 33 mm. So you don't have to know about this final book. You are easily getting the final book's thickness when you are picking the 5th book. That means you automatically know the thickness of the 6th book, even though you have measured only 5. Extrapolating this concept in a sample of size n, you know the value of the nth observation, even though you have only taken n-1 measurements. That is, the opportunity to vary has been taken away for the nth observation. And exactly this is one of the reasons why we do not consider n in terms of sample data. So in sample data, we consider n-1. That's all about this particular video about why n minus 1 for sample data and why not n. And see you in the next video.